For this Exopilot demo on modular procedural automation, I will review a basic drum discharging procedure. This shows the line diagram of the equipment along with a simple set of plain English instructions. There are three main sections of the procedure. First is the prep and permissive section. Next is the start pump section. And lastly, we have the start discharge section. The prep and permissives phase of this procedure specifies the valve positions and the system settings required to perform a safe drum transfer. The startup phase calls for the actions of the operator to start up the pump and provides guidelines for monitoring the system for stable pressure and flow conditions. The discharge section contains a ramping procedure. This ramping procedure provides low-level guidance within the SOP for ramping the flow. However, operators had more detail on this step as well as on all the other steps. We used the operator input to augment the standard operating procedure to completely document the actual actions that operators performed. This modified procedure is what I would use to implement an actual modular procedural automation project. In practice, we often find that the SOP just contains the basic information and has gaps in the details of what the operator actually does to accomplish a task. You really need to capture the knowledge of the operators and understand their real-world actions. So let's take a look at how we'd capture this operator knowledge and SOP with an Exopilot, Yokogawa's MPA tool. And just understand, when I say MPA, that means Modular Procedural Automation. All right, so let's take a look at the Exopilot tool. We'll use this tool to build the Modular Procedural Automation, or MPA application. I'll keep the modified operating procedure up along the right-hand side of the screen as a guide in building the MPA application. First thing we'll need to do is to start a new project. So I've done that here, and I've named it Drum Discharge. So what you do normally is just hit Build, New Main Procedure, and you type in the name of the procedure right here in this box and say OK. So first thing we'll do is go ahead and get a start terminal, because every procedure has a start and an end. So we'll go ahead and place a start and an end out on the procedure. The next thing we'll do is go ahead and configure the OPC interface. You don't really have to do that right up front, but several of you who were in my webinar asked me how you'd be able to communicate over your control system. So if your control system can communicate via OPC or convey information to an OPC server, then Exopilot can be used to work or act as a supervisory control over top of your controller, or even just provide guidance messages to the operator to take action. So the first thing you'll do is go ahead and go to Build and select Main Procedure Property. As soon as you do that, the Basic tab is shown for this configuration, and at the bottom half of that pop-up window, you'll see the OPC server configuration. It asks you for the OPC server name. When you click on the drop-down box, you'll see all the OPC servers that have been registered with that computer, that PC. And so you can see here I've got several third-party OPC servers, the TPN server, Experian PKS server, iFix, and some others. And I also have Yokogawa's OPC server called XOPC. So I'll select that one for this case. If your server is not listed in the list, it's okay. There's some procedure to go add and register your OPC server with your computer in the Exopilot system. And once it's registered, it'll show up in the drop-down box. Again, so I'm going to select XOPC for this example and click Apply. Once that's set up, now we can go ahead and start building out the rest of our application. And the first step is to go ahead and select the drum level and go ahead and check the drum level against the criteria of 60%. So D1LT01 has to be greater than or equal to 60%. So how we'll do that is go ahead and grab an AND block. An AND block allows me to go ahead and read from the OPC server directly just by using the tag.parameter namespace convention. So in this case, we can go ahead and either type in the tag name here, or we can copy it from the standard operating procedure. So copy this, I'll paste it right into the block. And then I have this relational drop-down box, so I can choose less than, equal to, greater than, equal to, not equal to. In this case, I'm going to say greater than equal to, and then 60%. And then we'll put a comment on here and call this drum level check. Okay, and so we're done. I need to go ahead and expand this. Or I can expand this if I had more text in here. You can see I can change the shape and size of this object. And that way I could add in more text here if I wanted to, saying that the level is at or above 60%. And then we can go ahead and say OK. I can resize this block to match the size for the text that's there. And then I want to go ahead and wire that up to the start block so the logic flows properly. So I can bring this up here and say from the start, the logic flow is going to go down into this level check where it reads from the DCS. The next thing we're going to do is go ahead and confirm the status of all 7 of these valves. So what I can do is build one, and I can copy and paste for the other ones. So how will I do that? We'll go ahead and use a confirmation message. So this is another object in the library that we can drag and drop into our project. And then I can just double click it to configure it. And the comment is going to be a drum discharge valve. And then we want to go ahead and use the message. We can use the text right off of the standard operating procedure. So the action is for it to be open. So we'll copy that. We'll say, hey, we want this to be open. And then the next convention I'm going to use is grab the tag name. So we want to say that open this tag, it's the equipment tag. Paste that in there. And then we'll go ahead and get the general description, drum discharge valve, right? So we'll copy that and put that into the Exapilot little object. And we'll go ahead and change the color of the text. I like to use blue for operator action messages. And then we'll go ahead and go under advanced. I can have an active sound or no sound. I'll leave this one active, but I'll make no sound for all the other ones. And for the display, I'll put a little display message in here that can then be used for display as part of prompting the operator. And the next ones I can create just by simply copying and pasting this down. That way it'll allow me to keep the blue color. So I double click on here, you can see I still have the blue color text. And then, but I actually want to remove the sound, and I'm going to turn off this extra display text. Okay, so I'm going to use a little movie magic to realign some of these and get the rest of the valves in place. So now that I've used the movie magic to build out the rest of these valve checks, we can go ahead and wire it up. I've already done that for the 7 valves. I've gone ahead and connected each of them with this little flow arrow, and I need to do that now for the level check. So coming out of the level check, we can simply left click on the node there and drag and drop that onto one of the nodes on the first drum discharge valve step, and then I need to characterize it just to say yes. So if it passes this criteria, then it'll go on to this step of check drum discharge valve, and it'll keep flowing on down and so on until it gets to this last check. So once these things are all done by the operator, the next step is to go ahead and put the flow control loop in manual mode and write a 0 to the output to close that valve, ensure that flow control valve is closed. And then we'll start up the pump. So what I'm going to do here is then grab a block mode setting object, drop that onto the screen, onto the project screen, and I'll drop on an output to PCS object onto the screen. This is to close the valve, and I need another output PCS to help me accomplish starting the pump. So let's go ahead and configure those. So we'll take the valve, copy this tag name onto my Exapilot. So I can put this into my tag name segment, and then for the mode, for this mode block, it asks me for the parameter of the tag name separately from the tag name itself. So I need to use the drop-down box and select mode. And then for the setting, it allows me to choose the enumeration. So I can choose manual. And I'll go ahead and label this as main flow control valve. And this is the flow control valve. Okay, and then I need to do the same thing. I need to set the flow control valve output to 0. So this is going to be the tag here, the NV, with the manipulated variable. It might be .op on your control system. It depends on your control system. And the value is going to be 0. And I'll just go ahead and put, you don't have to put a range in, but I'm going to go ahead and put the range in. And this is the flow control output. Output to flow control valve. And then the next thing we can do is start the pump. Once the flow control valve is closed, we can then go ahead and write to this pump. And it's getting a little different. I don't need the mode on the pump because the pump output is not a PID loop. It's a digital composite or a switch. So this is main pump, start. And we can put that tag there. In this case, this DCS uses a 2 to turn on the switch. Your DCS may use a different value or different enumeration text name for that, and you just need to type in whatever's appropriate for your control system. And then I'm going to go ahead and skip the ramping procedure. And really, my main goal here is just to show you how easy it is to go ahead and perform reads and writes and make decisions within the procedure. And that's mainly what I wanted to accomplish here. All right, so now I've completed the line if it passes the level check, but what happens if it fails the level check? For that, we want to go ahead and create an alarm message. So for the alarm message, I'm just going to put failed transmitter level check. And to make it a little bit more fun for us on simulation, I'm going to give the ability to recover from this. So if you have a failed check here, I'm then going to go ahead and have a confirmation message to allow the operator to try to recover from this failed check. And that's because I'm using, this is not connected to a real system, and I don't have an OPC server simulator running. It's going to fail this check every time. It's going to read a 0. So I want to be able to recover from that so I can show you how this procedure works. And so I'm going to go ahead and say perform site gauge check. So we can have the operator go out and look at the site gauge and manually check the level and enter a value. All right, and since this is an operator action, I'm going to go ahead and make this blue. And I'm going to show you a feature of the confirmation message that I talked about, I think, earlier, but I didn't demonstrate it. So you have 3 choices on a confirmation message. You can have confirmation only, selection, and setting. So under selection, this selection is what you'd use to then configure a set of selection buttons for the operator to select. In this case, I'm not going to do that. I want the operator to actually enter a value. I want him to read the site glass and enter a value. So I'm going to select setting. And then we can go to the setting tab here. And I can go ahead and enter in a value. I'm going to call this drum level. And it'll be 0 to 100. I can bound this to be 0 to 100%. Say OK. And then I can drag and drop on a parameter declaration down here. Below, I can actually place it anywhere on the page. I'm going to put it down here below the end block. If I double click on that, then I get a pop-up here. And I can now enter in the variable that I want to write to. So this variable here is going to take the input that the operator is going to enter and store it, because then I'm going to use that variable as another check, just like we did on a drum level check from the transmitter. We're going to do another check off the operator input to see if it passes the same criteria. Just because the operator entered it doesn't mean it's an automatic pass, right? It's got to pass this criteria here. And instead of looking at the DCS tag.parameter that's coming from the OPC server, I'm now going to use the variable that the operator entered to do that check. And then if it passes this, then I want to then go back into the valve lineup. So I can wire this to the same node that the transmitter drum level check is going to. You can have multiple lines wired to the same node. If it fails, let's go ahead and do an alarm on that. Then we're going to say failed sight glass check. Fill drum and restart. We'll go ahead and make this red. Okay, now I'm going to wire the no decision here. So I need to characterize this flow as no, and I need to characterize this line that I put into the valve lineup as yes. So now I have two flow paths depending on what the decision is from the AND block. If I fail a second time, I'm not going to allow the operator to re-enter a net value. I'm just going to tell them refill the drum and restart this whole procedure, and we'll end. Okay, so now all that's left is to compile this procedure, and then we can test it out. We can run it. And we select build, prepare to run main procedure. And then we get a pop-up box that lets us select some settings, and we say okay. And then if everything goes well, we'll get a correct syntax at the end, which I did here. I just want to go ahead and point out we do have a warning, and the warning says PC tag existence check will be skipped because OPC server is not connected or failed to authenticate the OPC server. That's a normal message you'll get when you're in offline mode or in standalone mode. I'm not connected to an OPC server or OPC server simulator, and I'm not connected to a real system. But we can still test the procedure if it compiles with correct syntax. So we'll select this tool, which is the operator user interface. The operator can either use this interface and a separate screen next to his process graphic, or he can choose to integrate the components of this tool into an existing operator graphic. So to get this to run, we're going to select drum discharge, and we'll go offline since we're in offline mode. We're not connected to a real system. And then we're going to go ahead and test the procedure. The first thing that happens is we get a starting drum discharge. And it gives a little audible here to alert the operator that the procedure started up. The next thing we hear is an alarm. All right, so what I did here was an alarm went off. So I selected the little alarm icon to bring up the alarm message list, and we see that it had a failed transmitter level check. And I selected OK, that silenced the alarm, let us know the operator could view that. And you still see that we have a remaining operator message waiting for us. And this is to perform a sight gauge check because the transmitter check failed, right? So everywhere you see this gray, that's the procedure steps that have already been executed by the procedure. The green procedure step is where the procedure is still on. That's the step that the procedure is still on. And where it's white, none of these have been executed yet. So you can see that we already went through, it automatically read in the level, and it didn't meet the 60% criteria. And then we got the failed transmitter level check alarm. We silenced that, and now we're on this perform sight glass check. So if I select this next step, it'll bring that procedure up. And I just want to point out right now, every component you see here, the flow chart diagram on the left, as well as this message list on the right, either one of these components can be incorporated into an operator graphic. And typically what will happen is I would incorporate this object on the right, where it's red highlighted now, where it says message. It would be a really small or real estate space, like as shown here, about this size. We'd put that up on the operator graphic, and you'd still see these action buttons here. And then when you were to select one of the steps that you're prompted for, you still get the pop-up right on the same screen as the operator HMI, the normal DCS HMI. So the operator can still interact with that. And in this case, we'll do the site class check. We'll say yes, 65%, and it'll help us go on. I'm going to go ahead and expand this back for this view, since we're not integrated with a DCS. It's just nicer to see us go along. So now we see that we did pass the test, and we're being prompted to open the discharge valve. And you can still hear a tone, and this tone sounds, I'm going to go ahead and silence it here with the silence button. That tone sound is because you may recall when I was developing the application for this very first valve lineup check, we left the tone on. That gives you an audible as well as this visual pop-up letting the operator know he needs to perform an action. So I'll say, and also I'll notate, or I'll point out here, I get this extra verbiage that I typed in. It says this display section allows for additional instructions, because I selected the little checkbox there for additional text space. These remaining sections don't give me the, if I select it, don't give me an audible. And if I select this, I don't get the extra set of instructions there. It just gives me the brief prompt that we typed in. Close the main discharge valve. So if I say OK on this step, then I'll go to the next operator guidance message, or operator confirmation guidance message. And that says close the auxiliary pump discharge valve. When I select it, it's asking me to go ahead and check on that valve, put it in the appropriate position, and it requires an operator response. So I have to say OK or cancel before the procedure will go on. Also, I'd like to point out it has a time of acknowledgement area here. So it has the timestamp for when the message came in, when this operator guidance message came in, but it doesn't yet have a timestamp of the acknowledgement. The acknowledgement occurs when you select OK. Once the operator selects OK, then this timestamp is placed into a log, and you can then use it to prove that, yep, you did all the steps, you did them in order, or it can be used to show that a step was missed by accident somehow. But it does that to help you perform further analysis if an event occurs. So we say OK. And then the next prompt occurs, and the operator would select that, read the message, follow the instruction. Once the instruction is complete, select OK. And then it goes to the next step, which asks for the strainer bypass valve to be closed. Once that's done, we can select OK. And then the procedure goes to the next step, asking for the inlet valve to the flow control valve to be opened. And once we've done that, then we're prompted to make sure that we close the bypass valve for the inlet valve and the flow control valve. So if you're not sure what that is, let's talk about this is the bypass valve to the inlet flow valve and the flow control valve. That's what it's talking about. So we can say OK to that. And then it's going to go ahead and put in the loop in manual mode, sent an output of 0, and it started the main pump. And now I hear a little tone because it's stopping the drum discharge procedure. As soon as I say OK to that, the procedure go ahead and closes, and now it's in the default state. And how the operator would then start procedures, he could just simply click on this run icon, select the procedure he wants to run, and run a new procedure. If this were integrated into the HMI of the operator control graphics, then our libraries have objects of buttons, and the buttons can be associated with specific procedures. And so the operator could also start procedures from within the operator graphic, if so chosen. And I didn't show it here, but you could also set up procedures that continuously run. So this one has a start and an end. We could have this loop back to a start, and the and could look for a Boolean value or a state to be met. And if something turns on, then it would run the rest of the procedure. Otherwise, it would just hold on this AND block. That could also be done. Okay, so if you'd like to see this full procedure built out, or you'd like to see a different kind of procedure built out from the one that we've shown in this example, just contact your local salesperson or shoot us an email. And I or one of my colleagues would be happy to go to your site or have you come visit us. We can go through the entire procedure, build it out completely, and show you some other neat little tricks that are associated with the product. Like the product also allows on each of these steps for an operator to kick off a link to a document or to a video to show more detail on what he needs to do. But I was just trying to keep it simple for today, just to give you a flavor of how easily an operator can get started using our tool. Thanks for your time. That concludes this webcast, but please contact us if you'd like more information.